Welcome back to Dr. Vipin's Biotech and Bioinformatics classroom. And today we talk about factors. And this lecture is in response to the request by Kenley Tenzin, who says that could you please make a video on factors as data structure. So here we are in our studio and we talk about the factor data structure in R, right? So before getting into the factor data structure, you need to know that there are two types of variable that we have typically in any kind of programming language. One that is known as categorical variable. So what is a categorical variable? Categorical variable is a variable which has a fixed number of values. For example, let's say we talk about days of a week. So we know there are only 7 possible days in a week: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, right? And likewise, if you talk of months in a year, so you know there are only 12 possible months. Likewise, you could talk of gender. So gender could be male, female, or others in that case, right? Then, of course, you could talk of marital status. So you could be married, you could be unmarried, you could be divorced, you could be a widower, right? So what I want you to do is to think of some more categorical variables and mention them in the comments. And then we move on, and let's say we create a vector of weekdays, and these are not in any particular order. So you say days equals to concatenate, and in round brackets with double quotes, you mention the names of the day you want in the vector. So here you are creating days equals to concatenate Sunday, Monday, Friday, Wednesday, right? So this is the vector that you've created. And then let's say we are going to sort this vector. So when you sort this vector, the default sorting happens in terms of alphabetical order. So let's run this part and see what we get. So here you are, when you run this, you get your days vector, and then after sorting, you get the order in terms of alphabetical order. So you have Friday first, then Monday, then Sunday, and then finally Wednesday, because W comes the last, right? Now, let's say what you have been asked to do is to sort this in the order in which the actual weekdays appear. So in which case you must have Monday first, then Wednesday, then Friday, and then finally Sunday, right? So how do you do that? So that is where the factors data structure can come in and be of help to you. So the question is, sort the days vector in the order the weekdays appear in a week. And for that, what you need to do is to create a factor data structure, right? So we'll come to factor data structure slowly. Let's first create a vector that contains all the days of a week and in the order they appear in the week. So here you are, you say week equals to, again, combine, and then in round brackets, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and then you close your vector here, and each of these values is in double quotes. Now, our job is to first convert this days vector that we had initially created. So this is our days vector that we had initially created. We want to convert it into a factor now. And while factoring, we need to keep in mind that our possible number of days are 7, and the order of these days is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, right? So what we're going to do is to first create a factor and then look into the properties of the factor. How do you create a factor? So we take a new variable name, that is weekdays equals to factor. And then, of course, we define the values that we want in our factor. So that is coming from the vector days that we've already defined. So this is Sunday, Monday, Friday, Wednesday. And then the factor also has what is known as levels, or the possible values that could be there in the factor. So this is coming from the vector that I've already defined, that is week, right? So we defined our factor here. We say weekdays equals to factor. So that is to convert your vectors into factors. And the factor would have values, and it would also have what is known as levels. So the values are coming from the vector days, and the levels are coming from the vector week that we've already defined, right? So you run this. Here you are. So those are your values: Sunday, Monday, Friday, Wednesday, as it defined in your days vector: Sunday, Monday, Friday, Wednesday. And then you have the levels. It says there are 7 levels, and the levels are Monday, Tuesday until Sunday, as defined in the week vector here, right? So now if you want to check whether this is a factor or not, you can use the command is.factor. So we say is.factor, and then we give the name week, DAYS. And you could run this to check if this is correct or not. If it is a factor, it will return your true value. If it is not a factor, it will return your false value. So this is basically a boolean that you're checking for. So here you are, you run it, and you see is.factor weekdays returns a true value, which means this is now a factor. So our original question was that we wanted to sort the days vector in the order the weekdays appear in a week. So we can say now sort weekdays, and this will now sort your weekdays factor in the order in which the levels have been mentioned. So here you are, you say run, and now if you see, you have Monday, Wednesday, Friday, Sunday, right? So this is in the order in which the days actually appear in a week and not in the alphabetical order. So basically what you have now included is the semantics of a week, right? So it follows the order of the days found in a week and sorts your days vector in that particular order. So what have we done till now? We have created a factor named weekdays, and this weekdays has 4 values and it has 7 levels. So levels essentially mean that these are the values that are allowed in the factor, and any other value will not be allowed. So now let's see how do you access individual values in a factor. And let me clear this out. So here we are trying to access values in a factor. Let's first print the weekdays for our reference. So you say run, and you have your weekdays here, Sunday, Monday, Friday, Wednesday is what we have in the original values, and the levels are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. 7 levels are there for us, right? Now, let's say you want to access the first value in the factor weekdays. So we say weekdays, and in square brackets, we say 1. So this is exactly the same way that we access values in a vector. So you say run here, and you get your first value, that is Sunday. All right. And then you also get the levels information. There are 7 levels from Monday until Sunday. Then let's say you want to access more than one position and you specify your positions with 1, 2, and you make a vector of that. So we say combine C1, 2 and put it in the square brackets. So we say weekdays and we open the square bracket. And within the square brackets, we create a vector with the positions that we want to access here. So we say 1 and 2. So we should get here Sunday and Monday. So when you run this here, you get a Sunday and Monday. And again, the levels information is displayed to you, right? Likewise, if you want to have a series from, let's say, position X to position Y, so you could use the is2 notation here. So we say weekdays, and in square brackets, 1:4. That is essentially printing the entire factor for you. So here you are, you have your entire factor, Sunday, Monday, Friday, Wednesday, right? So let's say you want to get all values of the factor except a specific position. So that you can mention by adding a minus suffix to it. For example, here we want all positions but position 3. So we say weekdays, and in square brackets, we say -3. So which means that we want Sunday, Monday, third position we want to exclude. So Friday will not be there, and you will get a Wednesday again, right? So here you are, you run this, and this is what you get. So you get Sunday, Monday, and you get Wednesday. You exclude Friday from here. So this is the third position that gets excluded. Now let's see how you can alter the values in a factor. We first print the weekdays for our reference. So you have weekdays for our reference. The values are Sunday, Monday, Friday, Wednesday, and the levels are Monday, Tuesday, and until Sunday in that order, right? Then you are looking at changing the value of the first value. So first value is Sunday. You want to alter it to Wednesday. So you can say weekdays 1 equals to Wednesday. So when you do that, you have the value here. So what this does is to alter the value on position 1, which was initially Sunday, now gets altered to Wednesday. And let's see if it is actually doing it. So we print weekdays again. So when you say weekdays here and you run it, you have a Wednesday now substituting for the Sunday that was there earlier. Now let's say you want to input a value that is not there in the levels. One important thing that we need to remember here is that when you're altering the values cannot be outside the levels that you have defined. So if in case you are trying to add, let's say week 1 equals to November, and November is not in the levels, November cannot be added. So when you do this, you'll get an error message. So when you run here, you get value November, invalid factor level, NA generated. So now what you'll get actually in weekdays is a NA value for position 1, because you tried to enforce a value that is not mentioned in the levels for this factor. So here you are, when you say weekdays now, you get an NA value here because this is because you're trying to insert a November that is not in the levels defined for this factor here. So that is where the importance of factors is. You could predefine the values that it can take. So before moving forward, let us recollect how we created our factor weekdays. So if you remember, we had initially created two vectors. One was days, the other was week. And then we created our factor weekdays by saying weekdays equals to factor. The values were there from the vector days and the levels were defined by the vector week, right? So another way of creating a factor would be to just define our values. So let's say you create a variable work equals to factor and you define just one vector here. You say combine Monday, Wednesday, Friday, Saturday, Sunday, Tuesday, Thursday, Friday, and Monday, right? So let me clear the previous messages. So if you run this here now, what you get is a factor that has the following values and levels, right? So this is your values: Monday, Wednesday, Friday, Saturday, Sunday, Tuesday, Thursday, Friday, Monday. And then the levels are from Friday to Monday to Wednesday. So if you see here, since you're not defined any levels, and you said that this is a factor data structure, the levels are automatically generated. So you have 7 levels, and this is arranged in alphabetical order. So you have Friday first, Monday, and at the end you have the Wednesday, right? So if you want some summary data for the work factor, so you could say summary work. When you run this here, so what you get in the summary is how many times each of these levels appear in your actual values. So Friday comes twice. If you see here, this is first Friday, and then you have Friday again here. Likewise, Monday comes twice. So Monday and Monday at the end. Then you have Saturday coming once, Sunday coming once, Thursday coming twice again. So you have the Thursday here, and you have another Thursday next to it, right? Then Tuesday and Wednesday come one each. If you want to see the levels, you can say levels work. And run this here, you should get the levels now. So here is your levels: Friday, Monday, Saturday, Sunday, Thursday, Tuesday, Wednesday. These are sorted in alphabetical order. So now let's say you want to add another level to the factor work that you've already created. So you could do that. You can say, so you say levels, and an argument to levels, you in the round brackets, you mention the factor name, that is work, equals to, and then C, and then again levels work, because that is the original values that you have, and with a comma, the additional value that you want to add here. In this case, you want to add a holiday. And then you close your brackets and you run this part here. And now if you want to see your levels again, so let's say we say levels work, you should have now an additional value, that is holiday here, right? So this is your holiday. And if you want to know the number of levels, you could say n levels work again. So if you run this again, this time it should give you a value of 8. And then, of course, if you run the work factor now, it should have 8 levels and the same values as before. So here you are, it has the same values as before, but the levels have now become 8. So you could do summary work, and that would give you, again, how many times each of these values has come. So let's now move on to a second example where we read data from a file, and then of course we look at a specific column which defines the gender of the participants. So we are looking at the marks distribution in a class in various subjects, and we are looking at first, of course, the column of interest for us is the gender column. We are looking at the males and females in the class, and we look at how many males are there and how many females are there using the factor data structure, right? So here we are. We first set our working directory to the directory where our file is. So my file is in the E partition. So I say set WD and in round brackets and double quotes E colon. So here you are. I'm setting up my working directory here. And I'm sure you also know that since you are in RStudio, you could use the integrated development environment to directly define your working directory using the session menu here, right? And we have already discussed this in a previous video, so I will not go into the details. In case you are not aware or you fail to recollect, you can go back to that video and check how to set the working directory using the session menu. We are into the E directory. Just to check, we say get WD, so we are in E. It says we are in E, which is fine. Then we read a file here that is using the read.csv command. So this is a CSV file. This is basically a file that shows you distribution of marks of several students in a class in certain subjects, right? So we load the file into the programs. So we say data1 equals to read.csv, and then we open the round brackets and we give the file name marks.csv. We are directly giving the file name because we are already in the folder where the file is, right? Or in the directory where the file is. And then we put up a comma and we say header equals to true, which signifies that there is a header in the file and the actual values appear from second row onwards. So here is what we have, and the file basically contains 31 entries, and there are 7 total columns. If you see here, this is the roll number column followed by the gender. This is the column of our interest. We'll convert this into a factor and look into how many males and how many females are there in this particular data set. Then you have student's name, you have subject marks, so marks obtained in English, marks obtained in maths, marks obtained in physics, and marks obtained in chemistry are given to you here, right? So let's go back and talk of factors now. So here you are. So we are going to access individual column in a data frame in base R. So that is done by using the name of the data frame, followed by a $ and the name of the column or the column header that you want to access. And then, of course, you're reading it as a factor. So we say as dot factor, and then as an argument to as dot factor, we give the name of the data frame. This is data1, and the header that we're referring to, or the column that we want to actually access, is the gender column. So we say $gender, right? And we equate it to another variable now. This is gender. So this is our factor now. So let me run this part first. Here you say run, and you have your gender factor created. You want to see the contents of the gender factor. So you say gender and you say run. And here you are. You have 31 values of males and females. And the levels are 2. Either it is capital F or capital M. Capital F represents female. The capital M represents the male, right? So if you talk of levels gender, it will give you 2 levels, F and M, right? If you talk of summary gender, that will also give you how many of the students are males and how many of the students are females. So it's a summary gender here, and you have your females 19 and males 12, right? So this gives you a total of 31 values, which is the actual number of rows in your data. So from a data frame, if you read a column as a factor, if it is consisting of categorical variables, you'll be able to find out how many different categorical variables are there and what is the distribution of each of the categorical variable in your data set, right? So that's the advantage with factors. So let's run the summary gender once more so that we know what are the values for males and females here. So as you see from the summary, there are 19 females and 12 males in this data set. So let's say we want to plot this data onto a bar plot, right? So we could convert this into a table and then plot into a bar plot. So we say bar plot and in round brackets table, and then in round brackets we give the actual column that we want to plot. So this is data1 $gender, and we close all the round brackets here and we say run here. We should get our first bar plot here. So here is our bar plot. If you see, you have 19 females and you have 12 males here. So now let's say you want to alter the order in which the plot is made. You want the males bar first and the females bar later. So to alter the order in which these are plotted, you will have to define your levels. And while defining your levels, you'll have to keep a certain order, right? That is the order that you want it to be in. So what we can do is we can extract the gender data as factor. And while extracting it as factor, we define our order of levels, which is going to be first male and next female. So here is what we do. We say gender 1 equals to factor. What is the data we want to convert into factor? That is coming from the column gender in data 1. So we say data 1 $gender with G capital, because that is how it is mentioned in that data set, comma, we define our levels now. Levels equals to combine, and we give the order in which we want the final data set to be represented in the graph. So we say male first, represented by capital M, followed by capital F, representing the females. And then we close all the brackets here. So what you now get is a factor. Here you are. So what you now get is a factor named gender 1. And in this gender 1, the order of levels is the male first, or M first, and F later. Right? So now we could use this gender 1 factor to plot our graph. So we say bar plot, and then as an argument to bar plot, we say table. And what is the data we are tabling here? That is the data inside gender 1 factor, right? And then, of course, you run it here. So here you are. Now, if you see, the male has come first and the female has come second now. So this is the advantage that you have with the converting our data into a factor. You could define the order of the levels, and accordingly, your graph will follow that order, right? So on that note, we'll close factors. I hope this has been useful. And then, of course, we move on to the next library, short reads, and we take a FASTQ file as an example and read it through R, right? Also, again, please do comment on the videos. Also share with your students, with your friends, with your batchmates, and the best way to share would be through the WhatsApp group, so that at least people take notice. And then, of course, depending on how much effort they put, they would be able to learn R, Python, NGS data analysis, biological techniques, basic bioinformatics, and command line genomics, and so on and so forth, right? Also do explore the channel and look for videos that you might like. There is also a whole lot of videos on recombinant DNA technology, which has not been accessed so much. So do have a look, right? Thank you very much. I see you again in the next video.